Okay, welcome back everyone. I am going to try and stall for about 30 or 40 seconds again, just in case there's a blackout delay that's been happening in my last few videos. So just to review, before we get into this next short lecture, which involves the steps of muscle contraction, what takes place in a muscle contraction, you need to review some basic terminology. You have to review the contractile proteins. You should know that they're actin and myosin. Actin are thin filaments, myosin are thick filaments. The regulatory proteins, which are troponin and tropomyosin, you just have to understand that and know that. They're regulatory, meaning they're part of the on and off switch of muscle contraction. And there are some structural proteins, titin, nebulin, alpha-actin, myomesin, and dystrophin. Okay, so once you go over some of those, we're ready to discuss what a sarcomere really is. But it is the basic functional contractile unit of muscle. It's called a sarcomere. And again, they are made up of regulatory proteins, tropomyosin and troponin. Those are the on and off switch. The contractile proteins, actin and myosin, and then the structural proteins like titin, nebulin, dystrophin, myomesin. And these are going to deal with alignment of the muscle fibers, its ability to stabilize, its ability to be elastic and to extend. Okay? So actin is composed of three important proteins. The important one is the G protein or the G molecule, which I'll show you, sometimes referred to as the binding site, tropomyosin and troponin. Now, tropomyosin is this type of protein that extends the entire length of actin, and it's going to cover the myosin binding site. So if we look here, this entire thing is actin. We have these F strand, right? This entire thing is an F strand, the purple blue spheres. And each of these is a G molecule. Each one of these purple balls or circles are the G molecule. Now, I want you to see that in the center of each purple circle, there's like a target. It looks like a darker center. That darker center is called the binding site. The binding sites are on actin. Well, something must bind to it. Tell me what binds to that binding site. Well, that's going to be myosin. Okay, the myosin head is going to bind here. However, the binding sites on actin are covered by this orange-looking protein, this string called tropomyosin. Tropomyosin is this orange-looking ropey string that spirals, right? And it covers the binding sites on actin. And then troponin, consider troponin to be the staple that holds this string in place. These yellow staples are holding tropomyosin in place. Okay, so now we have tropomyosin and troponin. Troponin is that yellow protein that holds the tropomyosin over the binding site. Tropomyosin covers the myosin binding site, so they work together. Okay, again, each of these purples is the G molecule. The dark purple is the binding site. The binding site for what? Well, it's the binding site for these myosin heads to connect to those darker circles. But here you can see that tropomyosin is covering the binding sites and troponin is the staple holding it in place. Well, how do we remove the troponin? How do we remove this staple? Well, that's where calcium comes in. Calcium is the key to the lock. Calcium is the staple remover. So troponin is the staple, calcium is going to remove the staple so that this tropomyosin can shift and move out of the way. When this tropomyosin shifts and moves out of the way, now and only now are these binding sites exposed. Now, where is this calcium coming from? Well, that calcium is going to come from the calcium that was stored in the sarcoplasmic reticulum. When this calcium is released, it's gonna like snow and sprinkle all over the sarcomere. Okay? All right, so here is myosin. This is the tail, and this is the head. Notice how many heads there are. There are so many heads attached to myosin, right? You can see down here, here's myosin, it has all these heads. Here, this purple structure, myosin, has all these heads. And remember, myosin is thicker. The actin, that would be the red lines here, these are thinner. Again, on the upper right, this is just showing once again each of these G molecules, these circles, has a binding site or an active site. In this case, they're yellow, but it's covered by the tropomyosin. And we see troponin holding the tropomyosin in place. Once calcium is sprinkled, troponin is pulled out, the staple is pulled out, all of the troponins are pulled out, tropomyosin shifts out of the way, and the binding sites are open. Once they're open, the myosin can bend. They bend like at this joint and this joint. And all of a sudden, these myosin heads move up and move down. They articulate or attach to actin, and they move it or slide it in, which we can see happening here. So here, this is the sarcomere at rest. Look at this H zone right here compared to the H zone here. Well, what happened between here and here? Here, a contraction took place. All of these myosin heads above and below attached to the actin and pulled it in to make a contraction take place. Okay, when we come back, I will review the steps that initiate a contraction and steps that end a contraction.